All right, hello. Thank you for watching this overview video of the QSys utility plugin Pick and Poke by Boombox AV. My name is Andy. I created this plugin. I'm very proud of it, and I'm confident it can really speed things up for a lot of QSys programmers. And maybe after using it, you might come up with some new ways to do things. All right, so let's get right into it. We're about to go over quite a bit of information, so please refer to the description below to easily jump around in this video. However, I would recommend watch the entire video before getting started with this plugin. I do think it'll save you time in the long run to watch the whole video first. Okay, let's start off with a feature overview of this plugin. So Pick and Poke is designed to help QSys programmers quickly and easily create UCIs for video matrix routing. So I personally found that creating UCIs for signal routing in even mildly complex situations was overly tedious and required too much custom scripting and control logic and layer management, etc. The freedom and flexibility of QSys is great, but I think you shouldn't need to get that far into the weeds for a pretty typical scenario for a design. So I wanted to create a utility plugin that was simple by default, yet didn't remove any potential for tons of additional customization when you do want to get fancy. Okay, so basically Pick and Poke is designed with 4 main elements in mind. First off, it's suitable for any size of installation, from a few conference rooms to visible rooms to a large stadium with lots of endpoints, lots of areas, UCIs controlling multiple areas, and lots of UCIs. Like I said, it removes the need for the programmer to manually create UCIs for all these areas and to be concerned with all the layers and the layer management that comes with that. So with this plugin, creating one UCI for 5 sources, for example, and like 5 destinations should take about the same amount of time as making dozens of UCIs for hundreds of spaces and thousands of endpoints. So scalability was a key design point. Number 2, it's suitable for any number of UCIs, and each UCI can be configured in the plugin separately. It operates independently, but they all stay in sync and they all show the current up-to-date routing information for when multiple UCIs are being used at the same time, which is how it's what happens. And thirdly, it's very customizable. It's easy to integrate with other design elements. It's not a black box. It will integrate with external scripts, plugins, control logic. So even when you are creating complex designs and interfaces, I still really confidently think this will help you, save you time, won't hinder you, won't back you into a corner to do things a certain black box way. And you'll just have to see how it works to maybe fully grasp that. And then 4th main point, it is hardware agnostic. Pick and Poke can be used to control nearly any video matrix solution or simple video switcher to video over IP networks. So as long as the hardware supports any sort of IP control, Pick and Poke should be able to generate a TCP or UDP control string for it. And additionally, via the use of user pins, it can control other plugins for hardware control, and advanced users, if you want to do this, you could even write an intermediary server script between Pick and Poke and the hardware, and you could intercept the TCP or UDP control data from Pick and Poke and do whatever you want with that to control the hardware, or not control hardware. You could do anything. So with this model, there's no need for Boombox AV to stay up to date and support specific models or brands or release new versions whenever hardware hits the market or whenever APIs change or anything of that nature. It will work for any combination of video switchers, video over IP solutions, even all of, a mismatch of devices and video matrices of different manufacturers all at the same time. And you'll see how that's possible later in this video. Okay, well, that's the end of the sales pitch. I know I just made some bold statements, so now let's get right into the details so you can see how all this is possible. So let's look at the properties. First off, you must paste the activation key from the email you received to take the plugin out of demo mode. And this takes away the time limit, and it will make it not clear the routing every time the design starts. Next, you set the quantity of UCIs. These are independent and uniquely configurable UCIs. So just set the quantity here. Next, here are the maximum number of source groups, sources, destination groups, and destinations to be displayed in the plugin per page. Now, the exact number of these items that you define in the JSON config, which we'll cover later, determines how many buttons are visible. But the values here determine how many buttons exist per page. And also, it helps with the scaling of the plugin window to be the appropriate size. It probably makes sense to set these a little on the large side, larger than you anticipate needing at first, because then you can add or modify sources and destinations later during runtime without needing to take the design offline and repush. Next, the buttons per row. Now, this is pretty self-explanatory, and the only purpose of this property is to make it easier to drag and drop buttons onto the UCIs. Next is the word wrap length for all group and source and destination and status labels. Mostly every button is affected by this word wrap length. And this will need to be set based on your fonts and your UCI design. So basically, whenever a line exceeds this number of characters, it will wrap that line to the nearest, at the nearest white space character, just as we're used to happening in word processors. And then max destinations. So this determines the maximum number of destination user pins and destinations visible on the Snapshots tab, which we'll go over later. And again, you can set this a little bit higher to allow changes during runtime with a JSON update, but clearly you can't modify the, it's not possible to modify the number of pins visible during runtime. So you set them here, and it can be higher than the actual number of defined destinations in the JSON. And then next, a pretty powerful feature, you can add custom buttons, and this will appear for every destination. A very common use I see would be to turn TVs on and off or raise and lower projection screens, but these buttons can do whatever you want. And these will map to the output pins in a static fashion. Because of how pagination works, the given location of a destination, the button might vary as you add and remove and modify the JSON. But for example, if you have a given destination, let's call it TV 16. If TV 16 is the 16th destination defined, no matter where it ends up appearing on the UCI after the group filtering and the pagination, the button will always map to destination 16's user pins. And that's obviously necessary to do whatever you want to do with the buttons. Now let's take a look at the interface of the plugin. First off, we have a tab for every UCI. On each is the list of source groups for that particular UCI. Next, a list of sources for the current page. And the number of buttons visible here depends on that max sources per page property. If the number of sources exceeds that quantity, we can navigate through the pages here, below. Now, these page navigation buttons are good for designs that have a lot of sources and or destinations. However, I would recommend using groups to split up the sources and destinations when possible, so the user doesn't need to page through them, except when necessary, when you need to for large groups. Similarly, under destinations, we see groups, destinations, and page navigation. They all work exactly the same as the sources. The Select All Destinations button, now this selects all currently visible destinations. In other words, all the destinations on the particular page you're on when you're using multiple pages or groups. Now, below, there are some rows that are unique to the destinations area. We have Destination Status. This displays the name of the currently selected source for each visible destination on the current page. Beneath that, we have our grid of custom buttons. Just to reiterate, these follow the pagination and group filtering. However, the output pins they output to are fixed, as I explained before. Okay, after all those UCI tabs, we see the Config tab. Now, besides the properties, 100% of the configuration data for this plugin is stored here. All other controls within this plugin are simply representations of data stored here. Understanding exactly how to build this configuration is important, and it's covered in our next section. A key feature of this plugin is the fact that you can add, remove, and modify groups, sources, destinations, UCI configuration, and everything else by simply pasting the updated JSON into this text area without needing to take the design offline or push a new file. There's no need to consider potential interruptions or signal drops associated with pushing a new design. So a good workflow for live updates would be to test the new JSON, maybe when you're emulating, while you're not connected to the AV network, so you're not changing sources while testing in the actual facility. And then once you have that tested and verified new JSON config, just copy and paste it into the live design. Pasting the JSON updates will not affect existing routing. You can do this during runtime design that's currently being used. Okay, so underneath the JSON text area, we have the JSON status. Now, this won't catch every possible mistake, but it will alert you to the most common errors, such as an incompatibility with the JSON and the currently configured properties. For example, having a different number of UCIs, or having more groups in the JSON than the maximum quantity of groups in the properties, or simply malformed JSON with a missing comma or missing brace, etc. Just to reiterate, getting the JSON perfect is critical to everything else working properly. So please focus on getting that JSON config correct. And we're here to help. The next page is snapshots. So the entire point of this page is to display a list of controls that can be scoped into snapshots. The first column is the name of each destination, just as a helpful reminder. The second column is the full group string for a given source. Now, this might not be which group it's displayed in currently on a UCI. It's the full group string as defined in the JSON. And you'll see how that works in the JSON config section. Finally, there's the stream ID. Now, you'll find out this can be an IP address or any other string used to uniquely identify a source. For example, for a simple video switcher, it would be input 1. If it was a video over IP network, it might be the IP address of the encoder or the source device. To create a snapshot, scope the second and third columns for all relevant destinations for that snapshot. Now keep in mind, when modifying any JSON string scoped within a snapshot, you'll need to recreate the snapshot. And finally, we have the licensing tab. This simply displays the current activation key as defined in the properties, the current locking ID of the core where this is running, and whether that activation key corresponds to the current locking ID. If it doesn't match, or if the activation key is blank, you'll see that it's in demo mode, along with the countdown. Next, I will discuss the JSON configuration. And sorry to disappoint, but I'm not going to verbally explain how to exactly create this block of JSON. There's simply too much detail, and I implore you to please read that section of the user guide thoroughly, and also look at the included example. To help create valid JSON, and to help catch little formatting errors, such as a missing comma or bracket, I'd recommend using a code editor, such as VS Code, or at least running it through JSON lint, which can easily be found with an internet search. Now that that's out of the way, I do want to show a quick demonstration of just how grouping can work in cases where you want a given source or destination to appear in multiple groups. As you can see here, I have an example venue with 3 floors, with displays on the east and west walls of each floor. All of these destinations only need to be defined once in the JSON. Now, the group names defined in the configuration for each UCI is simply used to search for all destinations which contain the UCI group name. You can think of the UCI groups as a search engine, and it just displays the search results as source and destination buttons. As you can see here, I can choose to display all of the TVs on an east wall, on a west wall, on the first floor, or on the first floor east wall. Another approach that works well is to put a list of all groups where a source or destination should appear as a list, separated by commas, spaces, dashes, or whatever. Then your UCI groups will just be one or more of those words to find those sources or destinations. Now, if the searching mechanism ends up requiring you to make group names that are not pretty, you could simply use the input and output user pins and select them with custom control toggle buttons. Then you can make the labels whatever you want with the QSys UCI editor. Also, with the user pins, you could also do the same with literally any button in the plugin. Okay, at this point, we've covered every aspect of the plugin interface. The last part to go over is the large amount of user pins available. As you can see, just about every user control has an associated pin. Most of it should be pretty self-explanatory. However, I'd like to go over the destination pins in particular. Under the destinations category, we have source group and source ID. If you want to use an external script or plugin to do the actual hardware control, you could use the source ID pin to tell the other plugin which source is selected. Furthermore, on the input pin side, you could get feedback from the other plugin to tell Pick and Poke the currently selected source for a given destination. When the input pin changes, it will update all the UCIs instantly with the destination's new source. By the way, this is exactly how the Snapshots tab works. In fact, they're the same exact controls. This is also how the plugin stores the routing state when you are offline, unless you're in demo mode, in which case it will clear these text controls during initialization. You can also see the custom buttons per destination. As I've mentioned a few times, no matter where or how many times a destination appears on any number of UCIs, they will always be mapped to the same pin. Similarly to the source ID pins, they have an input side as well. You can use this to set the UCI custom buttons status externally. For example, if you want to use snapshots to turn a group of displays on or off, you could create a custom controls component and scope its buttons to the snapshot and wire it to the input pins of Pick and Poke so that all the UCIs always display the proper state. Okay, you may be wondering, well, what's the exact reason for the source group input and output pins? Let's say you're controlling a series of identical rooms with simple hardware switchers. Every room will have an input 1 and input 2. Or let's say you're controlling a series of isolated video over IP networks, where a source IP used as the source ID may exist multiple times. Well, good luck with that network topology. But the point is, there's no reason why Pick and Poke cannot simultaneously control several isolated video matrices. The source ID alone might not be enough information to unambiguously define a source. Internally, Pick and Poke uses both the full source group string and source ID string to define a source. So, in a case where you have multiple sources with the same source ID, this allows you to unambiguously describe to an external plugin which source a destination is tuned to. For example, not just input 1, but conference room 1's input 1. The other aspect to quickly go over is the UCI tools user pins. This is very simple. These are trigger outputs that are fired whenever certain types of UCI buttons are pressed. These can be used for making interactive UCIs, to trigger a layer controller, for example. They simply trigger whenever a user selects a given type of buttons on a given UCI. Alright, well, I think that's enough for this video. Just to recap, we discussed the main design goals and features, dived into the properties, plugin interface. I briefly discussed the JSON configuration stuff. I showed you some grouping examples, and then wrapped up with some user pins. For full documentation, please read the user manual. Hope to talk to you all on the QSys developer communities. But I think that about wraps it up. I gotta go to my yacht and just go do some rich guy stuff. So yeah, don't be a stranger. See you guys later.